single stage CE amplifier. This is the another single stage CE amplifier. So we are combining the two single stage CE amplifiers, that is the two stage RC coupled amplifier. In this, the resistors R1, R2, R3, R4 is used for the biasing. What do you mean by the biasing? The biasing means in order to provide the external supply voltage to the transistor, we need the biasing. So the R1, R2, R3, R4 is used for the biasing the transistor. The RE is the emitter resistor or bypass resistor. The CE is the bypass capacitor. This RE is the emitter resistor. That means it is used to stabilizing the transistor in order to set the Q point in a stable way. CE is the bypass capacitor. If you want to increase the gain or if you want to decrease the gain, that is based on the bypass capacitor CE. CC1, CC2 are the coupling capacitor. The capacitor is used to allow the IC and block the DC. That means this is the CI, this is the coupling capacitor, CC1 is the coupling capacitor, CC2 is the coupling capacitor. In this, we are coupling the input voltage to the base terminal of the transistor Q1 through the coupling capacitor CI. The CC1 is coupled to the CC1 is the first stage output stage, that is coupled to the next stage base transistor Q2. That is the RC coupling. RC coupling. Resistor and capacitors are coupled. Okay. In this operation of RC coupled amplifier, first if you are giving the source voltage Vs, that means if you are increasing the source voltage Vs, increasing means Vs is greater than 0. If you are increasing the Vs, then the base current IB1 also increases. IB1 is increases. That means IB1 increases, so IC1 also increases. What's the relation between the base current and collector current? IC equals to beta IB. So the IB1 is increased. That means IC1 also increased. Okay. In that, this is the first stage output VCE1. Therefore, we are applying the VCE1 equals to the total supply VCC minus IC1 RC1. IC1 RC1. So IC1 is increased. IC1 is increased. So VCE1 is decreased. If you are giving the input voltage, increased input voltage, then you are getting the first stage output is decreased. That means 180 degrees is phase shift is in between these transistors. First stage CE amplifier, you are giving the positive sinusoidal signal, but you are getting the negative sinusoidal output. That means 180 degree phase shift in the first stage amplifier. So input amplitude Vs is increased, means first stage output VC1 is decreased. Vice versa. This is the RC coupled amplifier. We are giving the input as increased input, then we are getting the output as negative. That means decreased output. Frequency response of two-stage RC coupled amplifier. Frequency response. Frequency response means we are taking the frequency on x-axis, that is in the edges, and taking the gain on y-axis, that is in decibels. First the frequency is increased, after that it will tends to constant, then onwards it will be decreased. This is the FL, lower cutoff frequency. This is the FH, higher cutoff frequency. The difference between the FL and FH, it is the bandwidth. This is the maximum gain. The gain is represented in the A. So I am putting the AB max. This is the maximum gain. Next, this is the average AB max. Average gain, that is, there is a 3 dB difference in between the maximum gain and average gain. This is the overall frequency response. Couple. By using the coupling, there is an advantage. That means the bandwidth is increased. Bandwidth is increased, but gain is decreased in the amplifiers. The circuit is simple. That means the cost is reliable. We are taking only resistors and the capacitor. That is less cost. Thank you.